workshop this afternoon is to look at the software climate consultant. Hands up if anyone has used it before. Perfect. Great. Sometimes when everyone puts their hand up, I think, oh, what am I doing? Okay, great. So you can download it from here. This is a free piece of software developed by the University of California in Los Angeles. It's available on Mac or PC. And I think it is a really fantastic piece of software for understanding climate. And well, I'm going to run through and demonstrate some of the features, and then, as usual, go away, have a play with it yourself, try it out, try all the other features. It's a really user-friendly piece of software. I really think it's excellent. Okay, it's not really a sort of design simulation software. So it's not the kind of software where you're putting your designs in, but it's more to help you to understand the climate that you're working in. Is the volume okay? Yeah, great. So I've opened it up, takes you to the front page. Click on Next. Okay. It just takes you through to some more instructions. And it does mention the psychrometric chart tutorial, which I recommend you all have a look at. That's very useful. Next page. So, we have a choice. Continue a previous session, start a new project, or open a saved project file. We will start a new project. Let's just select the units to metric before we do anything else. And it's offering us now a choice of weather files. So we could open an existing, or we could download a weather file. So let's go and download one. Gives you the instructions here. It's all quite simple. Click on the button. Takes you to a weather site. Okay, this is the Energy Plus weather site, and let's go into Europe, and I think we will start. Let's just have a look. Let's just go to Portugal. Okay, let's have Portugal. So these are the available weather data files. So these are data files that are available around the world, and these are weather data files that have been collected at various weather stations around the world. Let's have Lisbon, and what you have to do, slightly unusual, you have to right-click, copy the link address, then you go back into Climate Consultant, and you click on the Paste Link button. And that will paste in that link to that weather file. It does explain that all there, but the sort of obvious thing to do is to click on the link and it downloads the weather file, but it doesn't add it to Climate Consultant. So just follow the instructions. Install. Okay, tells me that the weather file for Lisbon is ready to go. Great. So, takes you into the first page, and this is simply giving us the weather data for Lisbon in a sort of non-graphical form. Okay, not hugely useful, but that's the sort of raw data that we've got. And if you wanted to go and have a look into that, we've got lots of different data sets here to consider. Okay, just to familiar ourselves with the environment, along the top here, we've got some very basic tools. File, where you can save the project, you can change units. Criteria, where we can change the criteria that we are assessing this site, and you can change some of the color settings. Charts, which allows you to jump through these different charts in any order, but we're not going to do that now. We're just going to go through them one by one in order. And then the help is very good. If you click on the user help, you get user help files, and they will change. When you change your chart in Climate Consultant, the help file will change alongside it. So whenever you're in a chart, you can have a look, and it gives you some very useful instructions. So for example, here we're looking at the climate data. If I click on diffuse radiation, it gives us a little bit of explanation about what that is doing. So I'm just going to minimize the help file, and what we will do is we'll simply go next here, and now what it's asking is, what comfort model do you want to use? Now you can change this later, and it's offering us 4 different types of understanding thermal comfort. We talked about 2 of these this morning. So the California Energy Code comfort model, I won't use that. It's not really one that we use in the UK much. And we then have 2 that I would consider using. The first one is the ASHRAE Standard 55, which is the one I mentioned this morning, the predicted mean vote model. So this is the one where it's based on temperature, that you can adapt your clothing level. There's the adaptation that users of a building will accept slightly higher temperatures in the summer. Okay, so you could choose that one. There's also the ASHRAE Handbook of Fundamentals Comfort, which I'm not going to use that one. That one does use a lot more comfort cooling. And then we have the Adaptive Comfort Model, which is the other one that I mentioned this morning, the model which is relying purely on natural ventilation. So that would be a really good model for kind of Europe, for the UK. But what I'll do is, since we are looking at Lisbon, I'm going to use this model, the ASHRAE Standard 55. And we'll see what that means when we go through the software. So I'm just going to click on Next, down here. And the next page, it just outlines for you the criteria that we are using in that thermal model. So how are we judging thermal comfort? Now you don't need to change any of these, because these are the parameters that are set by that thermal comfort model. But you could actually start to change these if you wanted. Okay, and when you read through all of these, this is what it's basing the model on. So, thank you. Winter clothing indoors, long pants, sweater, normal clothing. Summer clothing, they're assuming shorts and a light top. Activity level, they're assuming the activity level is 1.1. Metabolic, which means you're sitting or reading. Okay, the predicted percent of people satisfied, 90%, as we talked about this morning. Comfort, lowest winter temperature, 20.3 degrees. Highest winter temperature, 24.3. Highest summer temperature, 26.7, because it goes up in this model. Maximum humidity, 84.6%. So you read through all of this, and it's defining all of the parameters that it will use to assess thermal comfort. Okay, next. Let's go to the next one. Okay, so we now move into the charts. And this is the real strong point about this software, is it's taking that raw data and it's putting it into some very meaningful charts, some meaningful graphics for you to use. Okay? And I really encourage you in your design projects to be taking these charts, putting them into your portfolios, putting them into your work, using them in a review, pointing to them, explaining to the tutors how you're understanding your climate. Now, this is quite simple software. In order to export these images, you just have to do a screen grab. Okay? It's very simple, but, it works. So if you're in a Mac, you can use Preview and go to Capture Screen. I'm on a PC at the moment, and I have this little snipping tool. I'm sure you're all familiar with this, and you can grab the screen, or I have a shortcut. Okay, now just grab that screen as a JPEG. Okay, I know it's not very fancy, not very complex, but it works. Okay, so let's look at this chart, and we have the months across the bottom, and we are looking at the temperature range, as it says here, and it always reminds us this is the particular thermal comfort model that we've chosen. Okay, we're in Lisbon, Lisboa, which is Lisbon in Portugal. Here's our latitude, longitude. Here's the weather station number. Here's the elevation of the weather station. Here's the time zone. So all that information is summarized. And then what we're looking on the chart is we've got some different color-coded bars. And these are showing if we just start with these little circle dots, that's the maximum recorded high temperature for that particular month. We've then got the yellow, which is the average mean daily temperature. Okay? And then we've got the green, which is what they call the design high and the design low. So that's kind of pushing beyond the average into the more extreme occasional temperatures. And then we have in white, the bar across the middle, the mean average. So in May, in Lisbon, the mean daily temperature is 17 degrees centigrade. Okay? It then summarizes the whole year into a single annual chart along the right. And then importantly, we've got these two grey bars. And as you see in the key here, these are our comfort zones for this model. The dark grey comfort zone being the winter comfort, and the light grey being the summer comfort, because as we've said, in this model, people will wear summer clothing and they'll accept slightly higher temperatures. Okay? And you can immediately, looking at that graph, you can immediately see that certain times of the year we will be dropping into that comfort zone. And then at other times of the year, our temperature is not in that comfort zone. And as a designer, that immediately highlights to you that there needs to be a design response. Okay, let's go through to the next chart. I'm not going to play with all of these tools here. You can sort of change the appearance slightly, but we'll just leave that. Okay, next one is the monthly diurnal averages. Diurnal meaning day-night. So the range, the temperature difference between day and night, or the radiation difference between day and night. So the key, as always, the key is on the left. And let's start with the more obvious one, which is the radiation. Okay, so if we let's start with January. The plot for January is a plot across a single day. And as you would expect, in the middle of the night, there's no radiation from the sun. Okay, so hence, we have this area with no radiation. See that? Then the sun comes up, and we have this range of radiation throughout the day. and then the sun goes down again, and there's no radiation. If we look at the same in June, we have a very different plot because we're having much higher levels of radiation from the sun. The breakdown then shows us the diffuse radiation. So this is the diffuse radiation reflected from the sky. The direct normal radiation, which is the radiation measured perpendicular to the sun. So if you pointed a radiation meter directly at the sun, that would be the direct normal. And in green, the global horizontal, which is adding both of the previous two ones together. Okay? That's the radiation. And then we've got the temperature ranges. And we have the dry bulb mean, which is the red line. The dry bulb temperature is the normal kind of understanding of temperature that we use, a dry bulb. And if we look at June, over here, our temperature throughout typical day in June, if we just scroll across here, it will be about 15 degrees in the middle of the night. That will rise up to 26, 27 degrees in the day, and then it will drop down again. So it's showing us this swing of temperatures throughout the day. Okay? And again, we get our thermal comfort zones shown in grey. Next one. Now, with all of these charts, they're not all going to be useful to you, and it's up to you to select the ones that you find are more helpful as a designer. They're basically giving you lots and lots of information, and you need to filter that out. Okay, radiation range again. Okay, so we've got the months across the bottom, and again, we've got that direct normal, global horizontal, and we also have this other metric, which is the total surface radiation. And what they're doing with the total surface radiation is, if we come down to this box down here, they're allowing you to have a surface and saying, well, you can input an angle for that surface that way, and you can input an angle for it that way. So, let's say, for example, we were looking at putting solar photovoltaics on a roof. We could change the angle down here. So I'll change that to 45 degrees. And when I hit return, just try and watch the graph, because it should change. Yeah. Okay, so I'll undo that, I'll put that back to 0. It goes back, change it to 45, and what's changing is just our total surface radiation, the orange bar. So it's telling us what the impact of angling that surface has on the radiation. We can also change the angle from south. So if I change that to west, again, our chart changes. Okay. We can change the reflectance of the ground. So at the moment, this is set on grass, which is quite absorbent. If you were in an urban situation, you might change that to, say, 40%, because buildings are more reflective than grass. Okay. You can also change the plot from an hourly average to a daily total. And I often find the daily total is actually a bit more useful. If we go back, the hourly average got a huge range of complex information. The daily total, it simplifies things down a little bit. Okay. So if we just start playing with some of our angles, and you have to put it back to the daily total, you get a sort of different understanding of the radiation. Okay. So really, what I like about this software is it's just so quick and easy. So here we are. Within 10 minutes, we're looking at a site in Lisbon, and we're able to look at the effect of angling a photovoltaic panel, or the effect of altering a roof, for example, in terms of radiation. Okay, next one, illumination range. We again have the direct normal measured pointing at the sun, and the global horizontal, which is all the light landing on that horizontal surface. So, as we said previously, solar radiation is proportional to solar illumination, so it's the same data, but we're now getting the figures in lux. Okay, and if we have a look, June, global horizontal for Lisbon in the middle of June ranges up to about 100,000 lux, with the mean at about 55,000 lux. If you, for example, exported that chart and then you reopened using a different location, for example, London, you could immediately compare those two sites. You can't, within the software, it won't let you compare two sites at the same time. Okay, so you would have to export, change location, export again, and that would give you two graphs side by side that you could compare. Okay, next. Sky cover range. So, we're talking about clouds on this drawing, on this chart. What proportion of the sky is covered by clouds? So if we look in July, the range of cloud cover for Lisbon ranges from 5% cloud cover through to about 50%, with the mean average at about 20%. Okay? So in Lisbon, in July, you are very unlikely to get more than 50% of clouds. It's not impossible, but very unlikely. This little circle at the top is the maximum recorded. So what it says there is that in July in Lisbon, there have been recordings of 100% cloud cover, but generally it's highly unlikely. Okay, and it's interesting when you compare that chart with the UK. It's a very, very different cloud situation in the UK. And again, I find this is such a revealing piece of software. If you move to a new site, so let's say I said to you, your new site is Delhi in India, and you've never been before, and you don't really know the climate of Delhi, you can immediately start to understand the climate of Delhi using this software. Okay, let's go on to the next one. Wind velocity. Now, as Abigail pointed out in the previous session, the thing to bear in mind with wind velocity is these readings are taken at weather measuring stations. And those weather measuring stations are not normally inside cities. So the wind recorded will often be higher than the wind you would actually get in a city. Okay, but there's the range of wind velocities for Lisbon, and I think what it shows quite clearly is fairly consistent low level of wind. No particular peaks. It goes up very slightly in summer, but no sort of huge difference. In a little while, I'm going to open the UK, and we'll have a look at the UK, and then we'll maybe look at a few other locations around the world. Okay, ground temperature. So we're looking at the temperature of the ground, and we're looking at 0.5 meter below ground, 2 meters below ground, and 4 meters below ground. And it's assuming a grass surface on top of it. This is very important if you are considering using ground source heat pump technology to extract heat from the ground. This becomes Very, very useful. And what you see in Lisbon is that in winter, the deeper you go, so when you go 4 meters below ground, that the temperature is warmer, and then in summer, as you go closer to the surface, the temperature of the ground is warmer, because in winter it's not getting a lot of sun to replenish that heat. Okay, you can, if you click on the fit to data here, that will just spread the data out. But I generally prefer to keep this on a constant range, because then when you change site, you're familiar with what that graph means. Okay, next one. We've got monthly plots, and we're looking at temperature, dry bulb temperature, and we're looking at the humidity. So the green dots, humidity, and the yellow dots being the dry bulb. Okay, and what you have to understand on these charts is that it's plotting across 24 hours. So an average day in January, at midnight, the humidity is here, dips a little bit at lunchtime, goes back up again. And there you can see what the temperature is doing. And again, we have our grey bands, which indicate the comfort level. And it's another way of visualizing when you are starting, for example here, to actually land in the comfort zone. Okay, similar one, I won't go into this one. Dry bulb temperature and dew point comparison. Dew point is important in terms of condensation. Next one. Okay, sun shading chart. Now, this is a useful early design tool for getting a feel for your window design. Okay. Now, in the simulation course, we'll be doing kind of more sophisticated studies in terms of window design, but this is a very good early design stage tool. So let's just have a little understanding of this graph. What we've got is we've got the plots for every hour in the year for Lisbon, and the color coding is telling you whether at that particular moment in the year it would be beneficial to have shading on that window to avoid heat coming in, whether you're in the comfort zone and shading might help but is not essential, or whether you're in a cold time of the day and actually it would be beneficial to allow the sun to penetrate through your window. So you've got these three coloured zones. It plots winter, spring, summer, fall, and I'm going to change that to the summer-fall plot for Lisbon, and you see we have a lot more red dots. Okay. We then have in the chart the time of the day moving around. So here is 8 o'clock in the morning, here is noon, and here is 4 o'clock in the afternoon. Okay. We then have the time of the year moving in the concentric rings. So this is December, this ring is September, this ring is June. Okay. So spend a little bit of time, in your own time, spend a little bit of time understanding what all these different lines are. And then we have the bearing angle, so the angle of the sun in relation to our window. So there's quite a few variables there. Let's just take an example. Let's say this dot here. Okay, what does that dot represent? So, if we follow its time, that tells us that it's 1500 hours. Okay, this line tells us the month that it's on, which is July. Where were we here? If we follow that vertically down, that tells us that at that point of the day, the sun is about 70 degrees from south. And it also tells us that the altitude angle of the sun is about 42 degrees from the horizon. So a lot of data, but it's putting all the information about the sun path onto a single diagram, and then it's also overlaying the periods in the day where you might want shading or you don't want shading. Okay. Now, as if that wasn't complex enough, I'm going to add in another layer now. Right? Now, you will have to go and experiment with this yourself, but it's a really good tool. So, I'm going to turn on the display shading calculator. Alright? Said it would get even more complicated. And I'll do my best to try and explain. So I've got a few little drawings first, just to show you. So here's a typical window. Okay, there's a person in the room, there's a window, and we're talking about here the horizontal shading angle, or the overhang angle. So measured from the horizon, what angle is that shading? So the blue line, if we didn't have this shading device, we'd be measuring about 65 degrees from the horizontal. If we add this shading device, the angle in red is about 45 degrees from the horizon. Okay? So that's in the vertical plane. Now, you then need to also consider the horizontal plane of a window. So here's a window. This is inside. This is outside. And again, we've got the angle from the center of the window to our window reveal, which is about 60 degrees. Or, if we added a shading fin, here that angle becomes about 45 degrees. And those are the angles that we're now going to use in the shading design calculator.